Welcome to our NPTEL program on power quality improvement technique. Today we are going to discuss the power quality standard. There is a research standard as well as the practical standard. We will discuss all the standard. So, we are going to describe the different power quality entities. So, first of all it is based on the characteristics of the voltage wave. We can have a power quality in voltage, current as well as the frequencies. So, frequency, deviation of the frequency, that has to be considered as a case of the power quality. Utility is supposed to give quality power, and the deviation of the power quality for the fundamental frequency should be 50 hertz or 60 hertz, and we have to restrict it within the specific limit. Thereafter, amplitude. So, that is the peak value of the voltage or current, that the long duration of the voltage variations. So, what we say here that measured voltage having a value greater than or less than the nominal voltage for the period of the time greater than 1 minute. So, that is something we consider that long duration of the voltage variation. The first one is called over voltage, and it is typically values from 10% to 20%, that is 1.1 to 1.2 per unit for the 1 second, and for the second one is under voltage, and it is typically the same 0.8 to 0.9 per unit. Voltage fluctuations, systematic variations of the voltage envelope. We shall see that in a waveform in later stage. Systematic variations of the voltage envelope or a series random voltage changes, the magnitude of which does not normally exceed the voltage range 0.95 to 1.05. So, that is we say that voltage fluctuations. The impact of the voltage fluctuations on lighting intensity, mainly if you have a lighting and all those issues, and subsequent impression of the under steady state visual sensation indeed introduces a flicker. So, that is something it will be constant to your eyes. So, voltage fluctuations has a very detrimental effect on the productivity in the industrial houses. Thereafter, voltage sag. So, that is quite important features. The decrease between 0.1 to 0.9, that if it is up to 0.9 or 0.8, we term it as a long term voltage disturbance, it is not a sag. Then generally we call it as dip or sag if it is 0.1 to 0.9 in RMS voltage at the power frequency for the durations at least 0.5 cycle to 1 minute, when the decrease is to essentially 0 voltage, that is less than 0 per unit, and for the very short interruption. Same way swell, it is a voltage increase in RMS voltage of the current of the power frequency for the duration of the 0.5 cycle to 1 minute, that will fall into the category of the voltage swell. Same way transient, you know that transient is a quite unpredicted phenomena, it comes and goes for a very small duration of the time. A sudden non-power frequency change in the steady state condition of the voltage, when unidirectional in the polarity, it is impulsive transient, all of a sudden there is a spikes comes and then goes in both positive and the negative polarity values, and this can be a oscillatory transient. Same way we can have the waveform, that is the problem with the harmonic contaminations, that is called the harmonic distortion. the presence of the frequencies, an integral multiple of the fundamental system of the frequency. Generally, if you have a, you know that it has a, if it is a 6 pulse converter, you have a harmonic contamination of 6 n plus minus 1, and harmonic combined with the fundamental voltage and current produces the voltage distortion. Similarly, symmetry of the 3 phase, that is basically unbalanced voltage, maximum deviations from the average of the 3 phase voltage divided by the average of the 3 phase voltage expressed as a percentage. So, that is also comes under the power quality purview. So, these are all we require to mitigate. So, once it comes, we require to mitigate, and we have a furthermore few more details. So, this is one important research standard. We have already defined those terms. We shall see that what are the implications of it. First of all, we have defined transient in previous slide. Transient can be impulsive. Impulsive can be further be classified nanosecond, microsecond, milliseconds. So, if it is 0.5 nanosecond or less than 15 nanosecond, and also microsecond 1 microsecond to 50 nanosecond, and similarly it is in can be millisecond to 0.1 millisecond to 1 millisecond. Thereafter, it can have a oscillatory. So, oscillatory, that can be a low frequency, it can be a very low in a kilohertz level, 5 kilohertz, and for the period of 0.3 to 0.50 microsecond, and its magnitude can be as high as 0 to 4 times of it, and medium frequency it can be ranges from 50 to 500 kilohertz, and duration will be little short, that means it will be around 20 microsecond, but its magnitude can be further high, it can be 8 per unit, that means 800% higher. Similarly, high frequency when it is 0.5 to 5 megahertz, and durations will be just very small duration of the time, 5 microsecond, and this is also generally up to 4 per unit. Thereafter, short variations, in that category we define the instantaneous. In that category we have a SAC, we have defined SAC, that is for duration will be 0.5 cycle to 30 cycles, and the magnitude will be, if it is in between 0.9 to 1, 0.1, we will consider that it is a SAC. Similarly, cycle will be same, that will be swell, 0.05 to 30 cycles, it will be 1.1 to 1.8, and thereafter you may have a momentarily some phenomena, that interruptions, that 0.5 through the 3 seconds, that is power is off almost, it is less than 0.1. Similarly, SAC for 30 cycle to the 3 segments, so it is same way, as well as swells for long duration 30 cycle to the 3 seconds and to 1.1 to 1.4 per unit. Similarly, that is instantaneous, thereafter you may have a temporary, you have interruptions same way 3 segment to the 1 minute per unit, SAC same way 3 second to the 1 minute per unit, swell is 1 minute per unit, and this will be the magnitude. And long duration variations, generally power interruption sustained for more than 1 minute, under voltage for more than 1 minute, and over voltage for more than 1 minute. Then we do not say it is SAC and swell, we call it under voltage, over voltage. These are while discussing this, what will be used frequently. So, please refer this standard, because once we will correct those entities. So, we are continuing with the IEEE 519. So, unbalanced voltage unbalance, that is in steady state it is 0.5 to 2%, that is acceptable in IEEE 1159 standard, and waveform distortion, there are different entities to it. DC offset can be as low as 0.1%, harmonics 0 to 100th harmonic, so it should be up to 20%. There is a intra harmonic. So, for example, it sometime comes, you have a 50 hertz supply in India and you have a 60 hertz supply in USA, and maybe you have chosen devices that has a switching frequency of the 720 hertz. But if you put this device in India, 720 will be a intra-harmonic. So, interharmonics, it should be in between that harmonics. So, 7.2 times, something like that. So, this will be the interharmonics, and it should be less than 2%. Notch should be 0, and the noise on the broadband should be limited to 1%. Voltage fluctuations, should be less than 25 hertz, and intermittent it should be 0.1 to 7%, and frequency fluctuation should be less than 10 segment. So, now let us discuss, this is the IEEE standard, and this is a distribution standard, has been followed in the European Union, and this is called EN 50160, and you see that for this is we almost follow the same kind of standard, mostly our Indian grid code. For this reason it is almost synonymous. So, the parameter, it is low voltage and the medium voltage. The frequency will be 50 hertz and should be plus minus 1%, and for the 10 second it should be and 95% of the weak grid, and we can have 4% or 6% for 100% of the weak grid. Magnitude of the voltage, nominal voltage of the system in RMS, and so this is this is generally 440 volt, and declared supply voltage, generally Germany instead of the U they write V. So, it should be around 35 kV RMS. Then the supply voltage can have a variation of 10% for the weak grid. Similarly, it can have also have a 10% variation. A rapid voltage change 5% of under normal condition, 10% under weak frequency control. Flickers, it should be less than 1%, and here also should be less than 1%. Voltage dip should be less than 60% for the duration less than 1 second. Majority of dip should be less than 60% for the 1 second. Some location, so we can have this kind of entities. So, harmonics voltage should be less than 5%, third harmonic, ninth harmonic should be less than 1.5%, 15th harmonic should be less than 0.5%, 21 harmonic should be less than 0.5%, and accordingly the total THD also should be less than 8%. And voltage harmonic 2% for 90% weak gate for 10 minutes and 3% in some location. and the short interruption for 1 second 100% and for the durations of the span of 20 to 500 years, and the long interruptions within the 3 minutes, and temporary over voltage it is up to limited to 1.5 kV RMS, and it can be as high as 35 kV 170% for the solidly impedance earth and 200% for the unearth or resonance earth. Shunt over voltage can go as high as 6 kV. So, now what is the implications of it? So, let us understand these are the disturbances, these are the cause, these will be the affected entities, and this is the solution. So, voltage variation. So, you may have a voltage disturbance, we have seen sag, swell, lot of entities. Mainly it is caused by variation and the other switching events that cause long term change in the system voltage. All of a sudden you overthrow a big line or you have a sudden fault, and due to that the variation of the voltage, premature aging of your machines, preheating and the malfunctioning of the connected equipments. To overcome that, we require the sensitive instrument to be provided with the line voltage regulator UPS motor generator set, so that it can give you the clean power to the motor. Voltage fluctuations or flickers, arcing condition on the power system, resistance whirling or the electrical arc furnace, they are making some whirling somewhere. Then what will happen? The disturbing effect in lighting system, like you are projecting, then there will be flickers. TV and the monitor equipment can be damaged permanently, especially CRT and other devices. Nowadays CRT is over. Installations of then how can you recover from it? That is installations of the filters, static burst system or the distribution static compensator. Now, transients. So, it may be from the many sources, direct lighting strike to the building or the transmission line, induced in the disturbances circuit by nearby the lightning strike, switching events such as capacitor load switching, switching from the fault clearing. So, it may damage many entities, upset barely noticeable with the self recovery like click in a sound system for a flash of the video screen, upset or burn permanent or the noticeable requirement for the VCR, TV, other sensitive equipments, even fans. So, you require to have a transient suppressor. Thereafter, you have voltage sag, fault in the network or the excessive large inrush of the current, and that is what it will do. It will be a malfunctioning of a lot of electronics devices, converter equipment with the electronic input, relays and the contactor can drop out, asynchronous motor can draw a current higher than its starting current and dips and recovers, and here also you require uninterrupted power supply, constant voltage transformer, energy storage in electronic equipments. It may be ultra capacitor, a new energy storage system such as SMEs and the flywheel can be the solution for the intermediate sag control. Now, similarly, there can be a swell, single line to the ground failure, upstream failures, switching off the large load or the switching of the large capacitor. So, what does it happen then? Trip the protective circuitry in some power electronic systems. It may cause damage to it, and over voltage always cause lot of damage to the insulations. Solution is definitely uninterrupted power supply and the power conditioners. Long interruptions of the power supply, distribution fault and installations. Current data can be lost for the system. After interruption is over, the reboot process, especially on the large and the complex system, can last for the several hours. You have habituated with it, because if your UPS is not working, all of a sudden power gone, and you are working in important data, that all are lost. So, for this reason you require a power backup, UPS or distributed power sources. And another important entity, I shall cover a lot of discussions on it. There is harmonic distortion, the nonlinear industrial loads, variable speed drives, welders, large UPS system. We are saying that UPS here, but UPS itself causes the distortion in harmonics. And nonlinear residential load and the commercial load, computers, electronics, equipments in offices, all are adding the harmonic problem. So, what is the problem of this harmonics? Overheating, and because ultimately it does not contribute to the real power. Harmonic power is, if you take in average, is 0, but since current flows to the resistive network, it will be unnecessarily hitting the elements. So, blowing of the power factor connections, capacitors, overheating of the supply transformer, we shall see in detail why it is so, tripping of the overcurrent protections, because peak may increase because of the presence of the harmonic, overheating of the neutral of the conductor, and this solution is provided by active power filter or passive power filter. So, with a short of discussion, because we require to complete our discussion in 20 hours, we shall put more emphasis now on the active power filter. Similarly, voltage unbalance, less than 2% unbalance is allowed in a single phase load for a 3-phase circuits. Capacitor banks, anomalies such as a blown fuse on one of the phase or any other reason, load unbalance may cause. So, ultimately if there is a unbalance more than 2%, then it will be a overheating of the motor, skipping some of the 6 cycles that is expected from the variable speed drive, and thus torque rating of the motor will be reduced, and to remove it we require a UPQC to release the allocation of the single phase load from the 3-phase system. Now, let us, I have pointed out, let us see the power quality as a business problem, why ultimately someone has to pay. So, what does happens? Loss of productivity, ideal people and equipments because of the power loss, lost order, goodwill, customers and profit, lost transactions if data is lost, orders is not been processed, revenue and the counting problem, customers and the management dissatisfaction, overtime required to make up the loss of work. Now, this is the some data I have captured with the courtesy of GE according to the electric light power magazine. 30 to 40% of the all business downtime is related to the power quality problem. Now, why it is so nowadays? Because of the scrambled data, uninterrupted communications, frozen mouse, that is your mouse is not operating, system crashes with the system failure because of the memory disturbance. Nowadays data is a we say now data is a new fuel. If you have a data, so you can do a lot of data mining, and thus data can be affected by the power quality. For this reason, we have to give the utmost importance to the power quality when there is a when you are dealing with the data. Now, high cost, who have been affected? Of course, there is a very smooth process control. For example, and the quality is a biggest challenge. For example, this semiconductor plant which is making, let us say, processor, you have to give a very accurate power supply and the manufacturing processes. Pharmaceutical, data center, that is why I am telling data centers are most vulnerable and they are the new fuel of the economy. For this reason, power quality has to support the data centers. And apart from the medium cost facilities, that is automotive manufacturer, glass plant, plastic plant, textile and many other plants, cement, cement, paper, pulp. And so, why? Because loss of production, there will be a lot of scrap, cost to restart, there is a extra labor cost, equipment damage, repair and other costs. Now, let us see, we shall define this IEEE standard in briefly. We will see that instantaneous sack moment, what does it mean by instantaneous sack? We have defined already, that is 0.5 to 30 cycles, momentary sack for 30 cycle for the 3 second and the temporary sack 3 second to 1 minute. Let us see. So, this is your short duration sack. Similarly, we can have an instantaneous swell and the momentary swell and the temporary swell. So, it is 0.5 to 30 cycle, 30 cycle to 3 second and 3 second to 1 minutes. So, this is the all of a sudden there is a sag swell. So, this is the instantaneous swell or the momentary release swell. If this comes into the waveform, we will say that. Similarly, momentary interruption, it can be 0.5 to 30 cycles and it can be also 30 cycle to the 3 second. See that there is a momentary interruptions for here I have made for the 2 cycles. If it happens, then it will be categorized as per the IEEE 1159 or 1995, this is actually 1995 standard, will be categorized as a momentary interruptions and the temporary interruption. Now, long variations, that is sustained interruptions for 1 minute, under voltage for less than 1 minute, more than 1 minute and the. So, this will be a sustained interruption, that is for the 1 minute, and we can have under voltage for the 1 minute and the over voltage also for the over minute. Now, we shall talk about voltage unbalance in a steady state and the voltage distortion. You can see that all of a sudden the voltage distortion comes. So, this is a problem. So, this is also comes under the power quality purview, we require to remove it. Similarly, we can have a DC offset, we can have a harmonic at steady state and the intra-harmonic, that is something quite interesting. So, this is the harmonic at a steady state and you can have a DC offset, that is your AC and DC does not match and sometime it is not exact multiple of it, then we say that it is the interharmonic. So, for the electric utility, control of the voltage and prevention of the outage or the power quality, we require to mitigate all the issues has been explained here. So, we have just discussed it, just recap. So, we can have a source of the PQ problems are lightning, power factor correction, we shall see in the next lecture maybe, and the power correction equipment, fault switching, these are the all are the cause of the power quality problem. Power factor correction keeps the power factor corrected, but it is detrimental. You will see that placing of the capacitor, that for corrections of the power factor, and what is its effect on the overall power quality. And so, these are the few issues, that is individual, and it can be internal sources, that is individual loads, that is lighting. Nowadays, we have LED light. So, elevators, coolers, HVAC, thereafter uninterruptible power supply, thereafter variable frequency drive, you got a battery charger, large motor during start, electronic trimming system, lightning electronic blast, arc furnace, medical equipment, MRI, etc. So, these are few categorized as a problem. Overheated neutral intermittent lockup frequency deviations. Disturbance type is steady state. It is because of possible causes are shared neutral, improper inadequate wiring, high source impedance SCS or rectified and notching harmonics, interruptions, then utility fault, inrush current. It can be intermittent lockup, lighting freckles, that is for the sags or swirl, component failure, dielectric breakdown, lockup, other things. It introduces the EMI or EMC. There are overheated transformer, motor voltage current, and that is causing the harmonics. Ultimately, possible cause may be electronic load, SCS or rectifier. Thank you for your attention. We shall discuss power quality issues and problem in our next class.